Guys, we're going to continue to use our definitions of our trig functions in the xy plane here to help us solve for some ratios with given information. So taking a look at say 6 and 7 here. Number 6, it says find the exact value of the cosecant of an angle if I tell you the cosine of the angle is 3/4 and that the cotangent of this angle is less than 0. So there's a couple things we want to read into this. And the first one we kind of want to acknowledge is just this right here, that on number 6 we were given a cosine ratio. And knowing that cosine is x over r, the cosine of an angle is x over r, we're kind of then just told two parts of our triangle. We know that the x part is going to be 3 and that the r part is going to be 4. And so, within this whole context here, we're going to know the x and we're going to know the r. The only part we're not going to know is y. Okay. The other layer of this is just that I kind of snuck in here, hey, by the way, cotangent is negative. And what this is supposed to do is at least give you an indication as to what quadrant this has to lie in. So remembering that we have a mnemonic here that we use to help us kind of keep in track of what quadrants have positive trig functions, all for all, trig functions are positive if they terminate in the first quadrant. S for sine, if you terminate in the second quadrant, sine is going to be positive. If you terminate in the third quadrant, then tangent is going to be positive, so T there, and then C for cosine. Any angle that terminates in the fourth quadrant, cosine will be positive. All the rest will be negative here. We're going to kind of try to narrow this down and see if we can't sketch a picture of this angle here so that we would be able to determine the value of y. And then go find our cosecant, which, being the reciprocal of sine, if sine is y over r, we really are just kind of after finding r over y here. So let's do this. If we know that cosine is positive, just because we observe it here, what quadrants could we possibly be in? Well, if cosine is positive, then we either have to be in the first or the fourth quadrant. So I'm going to cross these two off as possibilities here for quadrants of termination. And then we also are told that cotangent is negative, and that's kind of the same as saying that tangent would be negative. If you're negative, your reciprocal is negative. If you're positive, your reciprocal is positive. So if cotangent is negative, which of these two quadrants would we have to lie in? Well, we couldn't be up here because cotangent would be positive up there. So what this means is, as we sketch this situation, we're going to have to use our intuition to tell us what quadrant we lie in, depending upon the signs of these two trig functions that we're given here. So we know that our trig function lies down here. Well, let's do this. Let's find a point on the terminal side, drop it back to the x-axis here, and let's go assess the situation. We were told that cosine, which is x over r, is 3 over 4. Let's put a 3 for our x, a 4 for our r, and our first task is going to be going to solve for y. And again, this is just Pythagoras. Say 3 squared plus y squared would have to be equal to 4 squared. And in this case, that gives us a 9 plus y squared equaling a 16. Where when we follow up with this, I suppose we get y squared equals 7. And this is the key part here. We get a plus or minus root 7 as our y value. Now, looking at this sketch we made, it becomes very, very clear that this had better be a negative root 7 just because we're in the fourth quadrant. So to kind of sum all this up here, we were asked to go find the cosecant of this angle. Let's go ahead and write it then. The cosecant of this angle, which is r over y, that would have to be our r value, which in this case is 4, over our y value, which is negative root 7, which after we do our responsibility of cleaning this up here and rationalizing it, we get negative 4 root 7 over 7. So this is all we're after. We were just after a cosecant value. It's just that you got to know where the angle lies in the first place, and you got to know what it looks like. So taking a look at number 7, again, let's go find cosecant here, r over y. But we're told the tangent value, and we know that sine is negative here. So first things first, our tangent value is y over x. I'm going to acknowledge that we already know two parts of this triangle in this situation. And the other thing I'm going to do is go and sketch this. I know that, what quadrant would I have to lie in where tangent is negative and sine is negative? If tangent is negative, I could not be in the first or the third because that's where tangent's positive. And if sine's negative, well, the two remaining quadrants, I couldn't be in the second one because sine would be positive there. That means, again, in this particular situation, we have an angle that terminates in the fourth quadrant. So here's our angle. Let's go ahead and pick a point on the terminal side and drop our altitude. But we were told to begin with that the tangent of this angle is negative 15 over 8. So we know our y value, okay? We know our x value. I think it's important to note here that our y's got to be negative in the fourth quadrant, but x has to be positive. And the other thing we don't know is r. So again, using some Pythagoras here, I'm going to go a little bit faster. 8 squared plus negative 15 squared gives us r squared, and this adds up to a 289, which in this case, it doesn't always have to do this, but it gives us a nice pretty number here. So our r value would have to be 17. Okay, so in terms of plus or minus 17, in this case, you notice I didn't write plus or minus, but because it has to be a positive all the time. If it's an r value, it's a distance. So, looking at this, it says, hey, let's go find the cosecant of this angle. Well, we've got everything we need. We know the cosecant of an angle is the reciprocal of sine. So if sine's y over r, this is r over y, and our r value in this case is this 17, and our y value in this case is a negative 15. So again, knowing how to use your definition of your trig functions here. As far as number 8 goes, explain why secant of 270 is undefined. Well, suppose we could pop over to our unit circle to help us out with this one here, but this being our unit circle, 270 degrees, why would the secant at 270 be undefined? Well, if you look here, okay, secant is the reciprocal of cosine, and our cosine value at 270 degrees, so I should really write this here, cosine of 270 degrees or 3 pi halves, that's a 0. So to be the reciprocal of 0, I suppose, that leaves us in a kind of a sticky situation here. This would be undefined, okay? So it's undefined because the cosine value at 270 is equal to 0. So if cosine of 270 equals 0, then it's reciprocal. Reciprocal is undefined. Cheers.